Predictive analytics. So predictive analytics as in disease, whether particular disease is, we are still seeing it as a recovery phase or complications are still increasing. Okay, so based on particular medicine, whether the patient is responding well and all other things can very well taken care. We are in predictive analytics. So based on that only we can come up with early warning stable in an ICU for let's say critical patient or for example the patient who whose health is continuously deteriorating. So for those systems we can come up with early warning system. So this is also one of the key application of adaptive care. One more thing is like clinical decision support. So here decision support as in, so we all know that there is a huge demand for medical practitioners, but the ratio is not that good here in India. And this is also true even in developed countries where doctors are much required, but they don't have that much time that can be spared even to the critical patients, right? So same things are also available if patients are not available in the cities like Pune or let's say Ahmedabad or any part of metro city. So if the patient is at let's say small town, so how he is still able to get the desired guidance in the stipulated amount of response time. So this is all about clinical decision support system, which can be very well seen as one prominent application of adaptive AI in healthcare. And the countries like us, where 145 crore people are there, so only limited amount of medical practitioners do not suffice the need. So that is why these kind of systems are very much useful in today's context, or at least in Indian context. But again, there are set of rules and medical standards which needs to be followed, right? So complete information and all other guidelines needs to be followed very prominently. So even let's say radiology, let's say chest X-ray, which doesn't have any significant let's say disease that can be classified. So some of the X-rays are very much normal. So last week only we had a meeting with psoriasis medical professionals. They themselves have stated the figure like out of 190 X-rays are normal. But in order to get that normalization code from the doctor, the patient has to wait for hours or maybe for days. So if such kind of things are very well facilitated via our clinical health or AI assisted support system, then the time, significant time and work can also be reduced from both the parties. Both the stakeholders will be very much benefited. So that way we will see it as assistive system. And lastly, epidemic and resource management. So, just like in COVID time, we have seen that there was a huge need of ventilators, hospital beds, and certain set of medicines which are prescribed by the doctors. Okay, so how, with reference to changing dynamics of patients' data, patients' critical data, and the numbers, our system is still able to cater to all these increased needs in real-time mode, right? So, example which is very much prominent and we all have seen, witnessed, rather we all were planning in the COVID time, where AI systems adapted to COVID-19 data to forecast case surges, right? So this also we have seen there were many research papers, there were many reports, apps. Every day they used to also share the statistic worldwide, state-wise, country-wise, and also the prediction and forecasting. Okay. And based on that, hospital and all other healthcare staff will be prepared in advance. So it is all about proactiveness that can be applied and very well utilized using adaptive AI. Okay, so how it would work? So first thing is like continuous learning that is very much possible with new patient data, new clinical trials, and even new set of research paper, literature, books, or whatever knowledge bases that we have. So with reference to all these updated data, continuous learning has to happen. Context awareness we have already seen, right? So based on patient-specific factors, age, comorbidities, environmental changes, decisions would be taken by the system. So that is how adaptive AI works. But most important thing is like feedback loop. Feedback loop as in if my AI system has categorized some of the chest X-rays by mistake, or let's say we as AI scientists or AI developers, we are not able to detect all the fine-tuned level details via the chest X-ray and could still categorize it as, let's say, with some infection. So this kind of, let's say, mistakes, if at all captured by clinicians, then clinicians would be giving the feedback loop, and then there is a chance of now incorporating all these feedbacks to our AI system. So that way feedback loop is very important. So this is how adaptive AI would improve the performance and would also improve the accuracy. Okay. Last one here is techniques used. So in order to adopt this approach in healthcare, techniques might be online learning. Okay, so where every day now we all are using LLMs or agentic AI, generative AI, we all are tapping what all things are going across the head domain. So via these platforms, we should be keeping ourselves updated using online learning platforms, very good research websites which are there, which we should be referring, right? So these things can also be automated. Okay, so we should be having, or our system is able to capture, would fetch all the latest details from identify resources and would train itself. Okay, so this is online learning which is automated. Then reinforcement learning, we all know reinforcement learning is based on some kind of action and it's positive and negative feedback. Okay, so reinforcement learning is very much possible. Another very much prominent technique is federated learning, where we see that patient's data is very critical, right? Every day we keep on getting many calls, आपको credit card चाहिए क्या, आपको flat चाहिए क्या, आप flight book कर रहे हो क्या, hotel चाहिए क्या, like that, right? So we all know that our private data is very much open to all such entities, right? So now most specifically in healthcare, where patients' healthcare data needs to be maintained and that kind of sensitivity. Okay, so with federated learning, we will be coming up with very good secured network where patients' details, right? So be it, let's say, very generic report of blood or let's say hemoglobin or let's say thyroid that is getting shared, or there's a very sensitive report of having particular disease, right? So all such healthcare related data which is very, very sensitive, we can maintain it via federated learning. So that is why more specifically in healthcare nowadays, I encourage our students to make use of federated learning because the data is very much sensitive and we will never like if I'm getting the calls from in third party like some thyroid related aspect in your data, so get the treatment from thyroid care. So I would never like this kind of details of mine are shared with third party. So using federated learning, we can very well tackle the problem of privacy of patients. So this is how in general adaptive AI works. Benefits we all know. I want all of you to have attention of this slide. I won't ask you any question because there is a constraint, but please have attention on these pointers where benefits are seen. Okay, so benefits we all know, if we adapt this system, then outcome would be increased, efficiency of the system would be increased, efficiency as in manual work would also be reduced, and that way clinicians' time and even patients' time would also be increased. Okay. Scalability would be increased because the system, or let's say our AI system, it is trained on, let's say, 1,000 patients data. But now the patients are increasing. Now I'm having, let's say, 5,000 patients data. So how? With the scalability aspect, our system is still able to cater, still able to give the accurate result. So this is how scalability is one of the benefits. We also discuss like proactiveness, which can be maintained more specifically for the hospital admissions and even for critical patients. Then one more benefit, like with respect to federated learning, uh, uh, we have to maintain the patient's data, which is very sensitive. We are not supposed to share very critical health vitals to any other party. So that way there are standards like HIPAA standards and GDPR standards, which are set by European Union and also USA. So these compliance reports we will have to follow while maintaining all the details related to patient. One more thing or benefit that I see here is bias risk. Okay. So, India bias is very common problem in AI system, right? So bias will be unintentionally just expressed. Out of that, 90 are without any disease. So 90 X-rays are normal, only 10 are with some kind of abnormality. So that is a kind of imbalance, right? Bias can be seen in terms of, let's say, some of, uh, not here in healthcare, but let's say in terms of religion-based bias that gets introduced, in terms of skin color bias that gets introduced, even in terms of gender bias that gets introduced. So if you train your machine learning model on a data where woman is always seen working in the kitchen and roaming around with the kids, and if you are, let's say, training your machine learning model or deep learning model where men are always seen as driving or roaming around or playing football. So the kind of bias that you only have created in this system. So this is just an example, but biases would be like this. So maybe related to particular ethnicity, religion, gender, or any other. Maybe language related bias. Okay. And even poor quality data, if it is there, then also we have to take care. Then integration is very much possible. Like if we come up with intelligent system for, let's say, chest X-ray classification. So how we can integrate in the entire framework of full-fledged medical hospital automation. So this is also possible that we foresee here, and validation. So this is again very important thing. Like even if I claim that my machine learning model is giving, let's say, 98% accuracy, but validation from clinician's point of view is must here, because everything would be again dealing with life of a patient. So that is why validation would also be facilitated, and we will have to very well take care of this aspect here. There are real world good examples also, like IBM Connection Health is there. Also, there are very good feedbacks, variable bands, right? So all of you must be wearing and keeping tab of your health, like BP blood rise or rise, or you might be observing yourself, like if I have this kind of meeting, right? So this time say my BP is increasing. So this kind of just funny side. I would say that you yourself are now capable enough to see all the vitals which can be very well tracked via variables like Fitband and other stuff. Okay. Then Google Health DeepMind, which is there. So it more specifically works with imaging data. Okay. So I wish to mention an example here. In 2 months back, one of my friends had a problem with her teeth. So she visited the doctor, and then they had X-ray of teeth, and then doctor advised her to go for re-root canal. So she already had a root canal thing 4 years back, but now again her dentist recommended her to go for re-root canal. So she was skeptical like why again my doctor is suggesting this thing. So out of her curiosity, she uploaded the dental X-ray to there's a ChatGPT, simple, huh? Without any subscription wala model. She just uploaded that dental X-ray and the same kind of recommendation or treatment is suggested by ChatGPT. Now please understand this example and try to see the true potential of all these advances that we are witnessing now, right? So that way my friend has avoided the what we normally see in healthcare. We should seek for a second opinion from other doctors. So that means she could seek the second opinion from the system itself, right? Which is trained enough based on the available data. Okay, so we all know that with GenAI and ChatGPT, they are training themselves based on all updated data. Okay, so are you getting my point? Like all these things are very much there. Most of us are already started using it. I also keep on doing this thing like instead of reading all critical reports, जो भी मैंने last week test किए थे, which are of 10 to 12 techniques. I would just start after all the benefits and would try to ask more technical. The preparation aspect, and for that thing, we should consult our doctors. Okay. So, on that note, I would like to mention that all these systems which are there, they are seen as, or they need to be seen as assistive systems. But we are not going to replace the medical practitioners. Okay. So similarly, again, with reference to this FDP is for faculties or teachers like that, we all see that there is a huge, what you can say, decline in terms of software professionals. We keep on hearing, listening to the news like layoffs are very much, and they are increasing because AI has taken over their job. So we also see, and out of curiosity, we also discuss like whether this kind of system would replace the teachers like us. But at least in next 20 years in India, I don't see that there would be a replacement for teachers like us because there are still many human angles which are only captured by teachers like us, right? So that is why we see this all AI as assistive, not replacement to human being as of now. Okay, so more specifically in healthcare, ऐसा नहीं होने वाला. Though we see that there are many robotic surgeries which are now getting accomplished very well by the robots. Okay, but still, as a human being, there would be doctors and entire team of medical professionals, right? And as human being also, the patient side also, I'm not going to trust that particular robot 100%. Still want the doctor वहाँ पे रखते हैं. Okay. And here last point is connection to XAI. So XAI talks about explainable AI. Okay. So now we have seen that adaptive AI is what, why they are required, what kind of things they would do. So with reference to explainability, the topic that I will be covering now is like why particular recommendation is given, why this particular system is suggesting me not to take this medicine. So if I get this kind of explanations from the system, that I see that system is adaptive and also giving me explanations. So that is what connection to XAI is now discussed. Okay. So explainable AI, which is the next key term in today's talk. I hope the first point related to adaptive is very much clear. Okay, that was a kind of generic expectation, right? So the second topic is explainable AI. Why we now want explanation from our AI system. Okay, so it is all about tools and methods. Are you all with me? Coordinator, please reply. Because in
Yes, ma'am. Yes.
okay, I hope all of you are getting the idea.
Uh, I can turn on the mics if you tell me that.
नहीं ठीक है it's okay but online में मजा नहीं आता है.
Yes,
We are
yes,
traditional.
some feedback may required.
Yeah.
Yes, I will.
So, explainable AI is all about how we should be incorporating tools, methods, or algorithms, which will be then, I mean, intelligent systems, they are there with us. We are already getting the classification. Okay, this X-ray has been classified as a normal X-ray or with abnormal X-ray, right? So that kind of explanation, if I did, then only I would be trusting the system. Yes, ऐसा दिखा था. These are the, let's say, red dots which are seen on your chest X-ray. This side and that side is missing, and that is why you have to consult the doctor. So this explanation would enhance the trust. Okay. So explainability would help us understand what caused an AI system to reach a prediction. Okay. मुझको नॉर्मल एक्सरे में कैटेगराइज किया है क्योंकि कुछ एबनॉर्मल दिखा नहीं या फिर एबनॉर्मल किया है तो क्यों किया है. So if these kind of processes or methods or tools, if the system is generating along with the output, then it would enhance the trust on the system. Okay. One more thing is also interchangeably used with explainable AI is interpretable AI. So some of the times in some of the research paper articles, you would find that these are, let's say, alternatively used. Okay. But explainable AI is all about why. Okay. Why the particular decision has been made. Interpretable AI is about interpretation, right? How the decision is made, like a particular patient's BMI is greater than 30, BP is like 160, and all other things, right? And because of which the particular system is now interpreting that the patient with, let's say, some abnormal. Okay, so there is very fine line between these two concepts. But to have more clarity, just understand that explainable AI is all about finding answers for why, and interpretable AI is about how the decision is made. Okay, and so there are little bit differences, and as of now, you should be seeking like interpretability, focusing more upon understanding of inner working, like BMI was greater than this thing, and let's say BP was this thing, and there is family history of diabetes. So because of all these things, we should be understanding the inner working of the model, and it makes the system interpretable. Okay. Explainable AI is about why I have categorized particular patient as, let's say, if it needs an attention. Okay. Then model complexity, that is also one level of difference, and then communication would also be one level of difference. There are many pointers of overlapping for the concept of interpretable and explainable. As of now, understand the four like why and how. Okay. Apart from interpretable, one more concept is there. I don't want to bombard you with too many concepts, right? Because some of you might be hearing these concepts for the first time. So, causal AI is one concept. So, explainable AI is like why. Okay. So, uh, on the contrary, you see that causal AI, it could be also in line with interpretable AI to certain extent. But causal AI is like understanding and modeling both are related, right? So I'll give you one example specifically. Causal AI would like if patient BMI would be able to have been less than 25, patient age would have been less than 70, then recovery should be normal or patient category should be normal. So like that, each time the understanding and the data relation the interdependent if we find out, then it becomes causal here, right? Uh, so please explore now the concept of explainable AI, interpretable AI, and causal AI. Some of the research papers would use these concepts interchangeably. But causal AI would think about the relationship, like BMI का and PP का direct relationship है. So this would be the cause, right? अगर आपको PP normal चाहिए तो BMI should be less. So this kind of cause and effect kind of thing would be interpretable using causal AI. Okay, so why these concepts are important? Okay, so responsible, we see that our systems should be responsible. We should be trusting the decisions which are taken care, which are automatically taken by the system. So that way responsibility, then it would increase the confidence, and that way trust would also be increased. Then in long run, I would see that adaptation would also be increased, right? For example, out of 100 hospitals here in Pune, 10 hospitals have adopted that particular system, and patients are also enjoying. Even the medical practitioners are also utilizing that system. So that way, then more hospitals would try to see similar kind of adaptation. Okay. And regulatory compliances, like we all have to comply and also follow ethical guidelines by the system. Okay. Bias reduction, we have seen that this is common benefit with respect to adaptive AI. So if you look at this diagram, so black box approach is what we see that in deep learning, automatic feature extraction is facilitated, right? So let's say in CNN with respect to that X-ray, I don't know exactly which features have played the role, and X-ray has been classified as COVID-19 infected X-ray, right? So I don't know. So there is a huge confusion as a patient. But with explainable AI, I can very well find out that these are the red dots which are seen on the chest X-ray, and because of which the decision is taken by the system, like there is COVID-19 infection. Okay, so these kind of explanation would enhance the trust in the model. In simple, without healthcare ka example, if we see that this is the image of zebra, and based on which let's say features particular image is classified as zebra. Okay, so there are, let's say, most important feature is stripes, right? Black and white color case stripes which are seen on the body of the zebra. So because of which the classification is made as zebra. Okay, so 50% weightage is given to that particular feature which is stripes. Okay, then 20% maybe for legs, then 10% for hooves and all other. So likewise, my trust in the model would be increased if I get to know like these are the prominent features, and because of which the X-ray has been classified as cancerous one or likewise. Okay, so there are different approaches. So approaches as in there are methods of visualization, right? So there has to have uh, let's say some visual explanation. For example, in chest X-ray, if I see that heat map is getting generated with some, let's say, color code which shows the intensity, or some of the, let's say, blue shows the normalness in the data. So with that visualization also, we can convey the results using XAI. Another is like decomposition. Decomposition is like we will be, let's say, one complex concept, we will try to decode it into simple components, and that way we will further get the explanation. So this is another method, that is decomposition. There are explanations based on examples, right? I'll again show you proper examples for this header. So another approach is like improve explainability, is to provide explanations based on examples. Okay. So why that particular X-ray has been classified as abnormal? तो उसके लिए भी text में explanations दिए जाएंगे. So this is a kind of explanation based example. For example, in the recommendation system, I see that I have been recommended as a tie, right? Because I have already bought a blazer, right? So based on that, if a detailed explanations can also be given to the patient, it enhances the trust. Okay. So this is explanation based on example. And there are post hoc methods, like I have already applied particular method and then the system is generating some kind of explanation, right? The post hoc method. So these are the four approaches which are normally followed in XAI. So why do we want to adopt XAI? Because we want to make the system transparent. We also find out the insights from the data, and also if at all our system has generated some kind of errors, we need to have some scope of improvement. Okay, so with that explanation, we can probably get the thing convinced in better way. If the explanations are not convincing, then we will be giving our feedback, and that way error detection and correction would also be facilitated well. Okay. तो जैसे मैंने गलती से किसी स्टूडेंट को सिलेक्ट नहीं किया है फॉर अ प्लेसमेंट ड्राइव, ओके, though all the details were shared by the particular student. Okay, so if I show like these are the criteria and because of which I have shortlisted only 10 students, and by chance I get to know that particular student is not shortlisted, but there was an error with my side. Okay, so that way there is a scope of improvement. Then policy and decision making, right? And human AI collaboration would also be increased, because here we have to include the human being, human in the loop, right? So this is very popular term. Again, similar kind of diagram which will give you the idea, like there are critical features. Then your typical model, which is black box one, it has identified a particular thing, and then the patient is asking why a particular thing or particular uh, data is categorizing it as cancer, right? So doctor is explaining like you are diagnosed with breast cancer with a probability of 70%. Okay, so this is the explanation which is given by our AI model. And now the patient is asking why. Okay, but now if the patient, right, if the patient is getting this kind of explanation, more particularly, let's say, with respect to explainable AI, if red lesions which are seen in the mammography report, which are greater than 0.5 millimeter, and there are some other parameters also, because of which the X-ray or report has been classified as cancerous one. So these kind of explanations would be then helping for the patients. So this is a broader diagram for all explainable AI aspect. Like there are opaque models, there are transparent models, there is post hoc explainability which is available, and explanations would be like explanation by simplification based on feature, based on visual, and also local explanations. I mean, this is a topic, this explainable AI itself is 45-hour session course. Okay, so it would take a lot of time, but I will try to give you important pointers here. There are explanations like local explanation and global explanation. Global explanation is like particular things are observed in entire data, right? If I am having students data of teenagers where all the traits are written, so I am observing all the details and then reaching to a point that student attention span is declining, student is now focusing more upon, let's say, social media and all other stuff. So likewise, if I observe entire data and come up with explanations, right? So it becomes global explanation. Local explanation is like, for example, chest X-ray is given, one chest X-ray is given, and then I am categorizing it as normal or abnormal along with some explanation. So it is local explanation, जो one to one मैं करूँगी. Okay. So to summarize, global explanators, they give visibility into the model's behavior in general, right, based on entire data analysis. Whereas local explainers they are more into digging out specific case, right? Case to case basis पे chest X-ray देखा उसको cancerous non cancerous categorize किया. So likewise, global and local explanators are available. Visualization techniques like instead of talking, I want you to show more visual representations. So here visual representations like heat maps are available, graphs are available, some color codes are available. Some of the features can also be classified as patient's age or let's say blood pressure, and all other features can be uh, what can say rank, like patient's age is very much important. Okay, for example, I have to track the diabetic patient's data. So in that case, patients, let's say HB1C test would be the most important, then patients let's say family history would be the second important feature. So likewise, I'll be coming up with features with the importance and significance. Okay, then there are linear models, there are decision models, there are rule-based systems like if and else value systems. Also, in natural language explanations, if the explanations like the patient's elevated heart rate and history of hypertension contributed to the diagnosis. If these kind of natural explanations are given to the patients, it would be enhancing the test trust on the system. Okay. Uh, there are forms of explainable AI. As of now, I'll concentrate on the AI ethics guidelines. Okay. So there are rules like fairness, accountability, and privacy. Fairness, as in if I'm recommending something, like some kind of medicines to particular set of patients, then I should be fair enough. Like uh, if the patient is rich and for that particular patient I am giving intentionally some costly medicines. If the patient is poor and I am intentionally giving some very let's say basic set of medicines which are not at all effective, so that fairness I need to maintain. Then accountability, like if I'm trusting only on the AI based system and by mistake the system is performing some mistake, right, in terms of guiding or recommending. So who will be the accountable? The hospital or the AI system developers or the patient who himself has given the consent to go for that particular system, right? So in this case, accountability is very much important, right? So nowadays we see that ADAS and autonomous driving cars, they are there here also in India. So if that Tesla, if there are certain set of accidents, so whom we are going to blame, right? Whether the car owner or the developer, Elon Musk, or the country who has given the permission to set up their ADAS plan, right? So who all will be the accountable entities in this case? And that is why, more specifically in healthcare, we should be following to the European Union guidelines like GDPR or EUDR or even FDP guidelines, and the standards like HIPAA compliance reports. Okay. Then there are design frameworks where we say that very good visualization, that's dashboards which are available where we can very well track patients' data, all the vitals in real-time mode. And like on the hospital dashboard, as an admin, I should be able to see like kitne beds available hai, how many patients are seen as critical, how many patients can be discharged today so that we can still admit more patients. So that kind of design frameworks, and also human in the loop concept is very important because validation is very much important. Okay, so that is why HIPL is considered as one of the core in design framework. Then there are evaluation frameworks like accuracy. Okay, we all keep on checking कि model की accuracy क्या है, whether it is 70% or 90%. But not only accuracy, we should be able to also see the interpretability. Okay, so that is why nowadays only accuracy is not seen as the prime measure in AI or deep learning model. Rather, we should be having more evaluation frameworks. Okay, you need to see that if any customization is also made in terms of evaluation framework for your topic, be it PhD or be it any kind of project, तो कोई customized set of evaluation भी हम डाल सकते हैं क्या, right? So here I have specifically mentioned like accuracy or interpretability or end user feedback जिसके लिए हम system develop कर रहे हैं. So from them also, if we can get the feedback and then incorporate in our system to improve the accuracy again. So it will be a kind of iteration. Then factfulness, again it would be generated via the explanations. So there are popular models like LIME. LIME is local interpretable model agnostic explanation. I would straight away skip this theoretical part and would show you this diagram, right? Coordinator, please check, are you all able to see the diagram? Cat wala
Yes, ma'am. Yes, ma'am. Yes, ma'am.
Can you please interpret? What is your interpretation? Random answer is also okay. I'm talking about explainability. Okay, so here, what I do normally in deep learning, I would be giving the model, let's say 100 cats images and let's say 100 dogs images. Okay, and then would ask the model उसको categorize करो कि cat है या dog है. So in that case, this line model will also give the explanation. Only cat करके classify किया है, but why cat, why not dog? इसका explanation भी मुझे चाहिए. So how I can get it? So let's say using line model, which is local interpretable model agnostic explanation. Okay. So here the input image will have, let's say, heat map kind of things. Okay, so the interpretable model will try to focus which all important features has made the classification. Okay, so here superpixel not contributing to the prediction. Those are being classified into, let's say, orange color figure. Please pay attention towards right side. Okay, right side में you all can see that green color features or green color pixels are very important pixels because of which the classification of cat is done. Okay, so green wala part is important part and orange wala part is not that important part. Because of all the green pixels now, my model has identified it as a cat. Okay, so this is local or line ka simple example, which is visual representation. So not only for image data like this, but line is also applicable for tabular data, text data, right? Image ka example to we have already seen, right? So it is applicable for all kind of data. One more important explainable AI thing or tool is Sharp. Sharp is sharply additive explanations. Okay. So the difference between these two, ये दोनों बहुत ही popular है, Lime and Sharp. Sharp और Sharply दोनों बोलते हैं इसको. So Lime is all about locally explanation देना. Local मतलब ये cat है तो क्यों है? Okay. Sharp is about giving both the explanations locally and globally. Okay. So like this, please pay attention here for Sharp. So it would also give local and global, right? So global as in particular model is, let's say particular model ka feature. Let's say we have seen with reference to zebra image, uske jo stripes the, so it has contributed almost 50%. So likewise, if we get feature wise contribution from the model, it becomes sharp. Okay, so this is contribution of each input feature to the model score, right? For example, there are 10 features. So 10 features may say only important features are contributing more. Just like we have done dimensionality reduction earlier in unsupervised. So it is almost similar kind of logic, but this is all about explainable AI. So here also with sharply, and again for the same Katka figure, okay, same Katka figure. Now I'm getting the scale below. If you are able to see the scale, pixels not contributing वो left side में आ गए with the blue color, and pixels which are contributing more, right? तो उनका scale बढ़ता जा रहा है. तो contributing more में कौन सा आ रहा है? Which is darkest वाला orange वाला part is कैट का नोज एंड मुस्टैक वाला एरिया, राइट? कैट का मोर ऑफ फेस वाला एरिया, उसके बाद आ रहा है तो ईयर वाला एरिया, देन टेल एंड ऑल अदर थिंग्स वुड सब्सिक्वेंटली वुड कम इनटू पिक्चर, राइट? सो दिस इज हाउ विथ शार्प we will be getting the most important feature and then all other features which are contributing towards the classification. Then again it has got categories or variants like kernel sharp, T sharp, tree sharp, deep sharp and all other. So if you are interested more, you can dig out this. There are counterfactual explanations also. Straight away I'll jump here to the example. Counterfactual explanations are like this, right? The first example. So if my let's say loan application or let's say credit card application is declined, so why it has declined, उसका rejection चाहिए मुझको, explanation चाहिए for the rejection. So counterfactual example one कि आपको income increase करना पड़ेगा by let's say $10,000 or $10 whatever. Then another example counterfactual is like increase income by let's say $5 and also improve the credit score, right? So this is called as counterfactual explanation, right? So even in medical context, we see that if you have to classify, you want to classify yourself as normal healthy patient, then decrease your BMI score, then decrease or increase your physical activities likewise. So this is counterfactual explanation. So similarly, counterfactual explanation like stroke and non-stroke के लिए दिया है, right? Gender remains same, but if the BMI would be increased, then there are less chances of stroke. Okay, so this is how CFE or counterfactual explanations will work. Again, similar thing with reference to recommendation engine. Okay, so टाई क्यों मुझको रेकमेंड किया है यहाँ पे, क्योंकि मैंने ब्लेजर लिया है या फिर वाइस वर्सा. ओके, so here if you see the explanation or read out the explanation, so it could be like you purchase tie. If you had not purchased a tie, then all items remain the same, recommendation results would have been different. Okay, so this kind of explanation would enhance the trust on even recommendation system. So this is again feature wise importance which is given. Then there are TSNE like distributor stochastic neighbor embedding systems. Likewise, a kind of clustering that we have seen in unsupervised. Okay, so dog के pixels एक side करना, horse के pixels एक side करना with different color code. So this is a kind of again unsupervised but for explainable technique. Then occlusion sensitivity, again this is related to explanation, visual explanation. Okay, so a dog image is given. There are different occlusions, right? Highlights of occlusion, mask movement over the input image, the way we have seen that CNNs normally work. So यहाँ पे भी in occlusion sensitivity, this part would move, right? This mask, occlusion mask would move on every frame and then ultimately would find out the heat map, right? So heat map and the final result would be like the important parts of the dog, right? Uska face, uska nose, uske ears, and all other things are contributing more. Okay, so this is occlusion sensitivity. One more approach is available, that is layer wise relevance propagation. Okay, I would directly show you the example. Okay, so the input image is given and then it has been classified as rabbit wala image. But again, layer wise, right? Because in deep learning we see that there are multiple layers. So if layer wise explanation is also generated using LRP technique, it would enhance trust, right? आउटपुट तो सेम ही आने वाला है रैपिड, बट लेयर वाइज भी अगर मुझको और क्लैरिटी एक्सप्लेनेशन आ जाएंगे तो इट वुड बी मोर ट्रस्ट वर्दी ब्लैक बॉक्स और डीप लर्निंग का मॉडल. Again, same thing, layer wise, if I'm getting explanations, right, that particular thing is a rooster, then it would be very much trustworthy or explainable system. Then one more prominent technique is GradCam, gradient weighted classification activation mapping. Okay, I'll straight away show you the example. Okay, so again, input is given, your GradCam model would come up with the heat map and with the features which are contributing more. One more technique is there, that is ELI5, explain it like I am 5. Okay, so simple techniques like petal, sepal, so क्यों classification किया है into different categories. So this kind of explanation is also available, like sepal length, sepal width, petal width, and based on that particular flower category is classified. There are certain rule-based extraction techniques. There are feature importance techniques like this cholesterol.
Hello?
Yes, yes,
No, your screen is not visible. So are you sharing or?
yes. Continuously, I'm changing the slides.
Ma'am, just last one, in a 1 minute it is just bored. So you share it again.
Okay, कौन सा वाला दिख रहा है आपको?
Ma'am, only camera output is visible.
Oh, okay. अभी is it seen? ये आपने देखा था ग्रैड कैम?
Yes, ma'am. Yes, ma'am. ये देखा था और visible. Yes.
Okay, okay, okay. Thank you. You are very much prompt, and that way I'm happy कि you are paying attention.
Thank you, ma'am.
Okay, okay. So again, this is ELI5 is a technique where based on the criteria we can categorize the variety. Then there are rule-based extraction techniques. So the screen is visible, right? For example, heart disease के लिए which all important features that are being identified by our system, right? So for example, cholesterol or thalassemia or maybe age. So all such features, they are having importance in the classification. Okay. So this is a global feature importance technique. There are fuzzy rule based systems, there are PDPs, attention based systems, there are rule extraction based systems, and many other. Even there are graph based explanation systems, right? So you can also explore these things as per your free time and also as per your interest. Okay, so there are many applications like diagnostic imaging, even personalized medicine, variables, predictive analytics. Still, there are challenges in terms of scalability. Then trust needs to be enhanced because this is primarily black box model and technology is still, I mean, everyone has to see technology as a strength, as supportive system. So trust building, that is also one of the challenge, and see it as a future direction also. Then integration with already existing medical systems or EHR system. So that integration is also a challenging thing, and whatever advancements which are coming up in the medical field and also technological field. So accordingly, we should be also adopt ourselves. So there are challenges like confidentiality of the data and also the system, complexity, fairness, bias, we have already discussed. Then these are the links of freely available interpretable tools. Of course, I'll be sharing these slides with the organizers, but these are the tools via which you will have to, I mean, Python-based libraries are there, and you can directly incorporate them in your code as per your requirement. So here with this slide, we see that the adaptable approach and also explainable, interpretable, causal approach, we see that we are trying to evolve towards responsible AI, right? बस एक system develop करके we have just left it to the user ऐसा नहीं है. We are still taking care of the explainable aspect. We are still maintaining the compliance which are required. We are still making the system secure and make the data secure, privacy and ethical aspects are also maintained. So that way human-centered machine learning is also attained, and we see this as a bigger picture where we call our systems as responsible AI systems. Okay. So discussion on the technical perspective, this is very much required. Technological perspective like teachers or academicians or researchers and also medical practitioners. Discussion from legal point of view like robotic surgery अगर fail हो जाती है, patient by mistake अगर मर जाता है, तो किसको blame करना है? So in this case, legal compliances, legal perspective needs to be studied, medical perspective, even the patient perspective needs to be studied, and all other things needs to be discussed already. Yeah, they are in discussion. Okay. So to conclude today's topic, I would say this is heavily debatable topic, explainable AI or even AI को direct system में integrate करना. Okay, but still with reference to GDPR in European Union, there is a lot of advancement and positivity in terms of adopting AI and with explainable AI, of course, because we are dealing with patient, which is very much sensitive. Okay, we are dealing with a human being, not with, let's say, स्टूडेंट अटेंडेंस वाला कि स्टूडेंट गलती से भी एब्सेंट मार्क हो गया तो भी कुछ प्रॉब्लम नहीं है, बट नाउ वी आर डीलिंग विथ अ ह्यूमन लाइफ, सो दैट इज व्हाई वी शुड बी वेरी मच केयरफुल. Okay, so we will have to sensitize developers towards all these aspects, even the healthcare professionals and also the legislators. So final remarks would be like transparency builds trust. With explainable AI, we are going to make the systems available with explanations, right? So both the stakeholders, clinicians and patients will be benefited. They would also understand the decisions. Then adaptivity drives relevance. Okay, so as compared to already existing systems or traditional systems, our adaptive systems, they are able to cater to new data, new records, new medical knowledge and all other requirements based on real-time patient needs. Okay, then collaboration is the key. Yes, it is there because our AI systems, they are there to augment human experience or to assist the doctors, right? But not to replace. So collaboration to hamesha rahega, right? And better outcomes for safer care. Okay. So safer care, like let's say after 10 years, we never know what kind of AI development would be there in our day-to-day life. Okay. So we all should be positive towards its adaptation in our day-to-day life. And that way, this ethical AI, explainable AI, adaptive AI will be very much there, and it would revolutionize entirely the healthcare system. And the future is human plus AI synergy. So with all these concepts, when we see that there is a full-fledged ecosystem of healthcare professionals who are very much positive and trusting AI-based systems and also giving positive feedback, and that way AI practitioners, they are also incorporating those feedback. So it has to have a good synergy amongst all these stakeholders. Okay, and that way we can definitely change the print on entire ecosystem globally. So last but not least, explainable and adaptive AI isn't just a tool, but they should be working as a catalyst for healthier and more inclusive future, right? And that future, of course, we will be part of those future things and all these advancements that we are witnessing now also. And we are very much positive and excited to see all these advancements in coming years. Okay, so these are the references which I have referred for today's session. And thank you so much. So this is the email ID. So in case of collaboration or any guidance, you can contact me on this ID. So with this note, I'll end my session. Now the forum is open for questions or discussions or any other stuff. Organizers, please unmute the participants.
All the participants are unmuted. You may ask questions one by one.
Ma'am, I do have a query that
Yes,
which
please.
model is suitable for our application. How we can decide this local interpretation, global or shape wala?
Again, it depends on the use case or the data. If you want to find out, let's say, statistic or trend or some kind of recommendation or analysis, so in that case, you should be going for global model. If let's say one patient X-ray is given, dental X-ray is given, or one report of a patient is given, then go for local model.
Okay, ma'am. Thank you.
Okay. Are there any questions? I'll be also sharing my PPTs. You can refer them later on, and we can again connect sometime later on.
Ma'am, how do these adaptive AI models learn continuously without compromising patient safety?
Hello?
Hello? Yes,
Maitri.
yes, ma'am. So I would like to know that how this model learns continuously because it analyzes the data and then again the new data is getting fed to the system. So when we are talking about the patient system, so how it learn continuously without even compromising patient safety?
Okay. So patients' safety and privacy related things, I mean, this is very critical aspect. And every our data is very much public, at least in India, people are not at all bothered to share all the details, right? Kitne bhi private ho, our data is open. So this is really challenging thing, but with reference to the technology which I have mentioned, federated learning, we can still maintain patient's privacy in this case and keep all vital details only with the system. Though instead of putting everything even on cloud, even if the data is available, but let's say only that particular patient could access that data or related to that only particular doctor would able to get the report. Each type of privacy related framework is available, that is federated learning. So big data analytics would also be there at help because even in big data, we know that data would be generated every second in real time, let's say CCTV footage or any other transaction data. But still with the big data framework, we can keep tab of all the data which is coming as new data and then again train the model on newly updated data and come up with our, let's say, new system.
Okay, ma'am. Thank you.
Excuse me, ma'am.
Yes.
First of all, I appreciate your session, and the best part was the examples you gave.
Thank you.
Ma'am, I'd like to ask you that how do what would be the roadmap for our pharmacy students to go towards AI in healthcare? I mean, after their B.Pharm or a PharmD, should they do data analytics or what would you suggest for them to be on that platform where you're talking about all this kind of AI tools? how they connect. Yeah, can you just suggest some roadmap for them?
I mean, I have heard there is a lot of work which is going on in terms of drug discovery, because there are many permutations, combinations which are going on in your field, and it takes years of experiment. So these things can very well analyze and predict it using our model. And then later on, whatever things, like even if some kind of data analysis or maybe country-wise trends, if you want to spot, you can very well get it done using AI machine learning stuff. Explainable AI is more of generating the explanations, like why you are going to recommend particular drug to a patient. So on this line, you can definitely come or make use of explainable AI. But on bigger picture, you see it for all the things like the drug discovery or finding out trends or finding out side effect of particular drug on patient. As of now, I can recall only drug related aspect. But in pharmacy also, there might be many more things. So maybe if you are interested, we can connect offline with detailed
Yes,
challenges.
please. I would like to connect with you offline so that I could guide the students accordingly.
Yeah, definitely.
Yeah. Yes. Thank you.
Thank you.
Excuse me, ma'am. Myself, Raghavendra. I have one doubt that if anything fails in a robotic surgery, whose fault is it will be considered? Like you have discussed the things, no? I wanted to know that.
Mm-hmm. Yes, that is what I'm saying. In India, as of now, we don't have our India Q policy as such. Okay. So we just follow US Wali policy, which is we see that HIPAA compliance is there for that particular system. So that is why here, whatever things I have seen so far discussed with reference to my family's operations using robotic surgery, doctors are still there. So in that case, the hospitals needs to be, they are accountable for any mistake. अभी के लिए, as per India's policy. As of now, we don't blame the production house or production company जहाँ से जैसे जर्मनी से कई robot लाए. So we don't blame those manufacturers in this case. But still, it is yet to come. जैसे अभी autonomous cars भी आ रहे हैं, Tesla is also coming, right? Manufacturing things are already started. तो उस केस में एक्सीडेंट हो जाता है by that car, तो whom to be blamed, right? The driver, owner, या फिर manufacturer, या फिर the infrastructure. So these kind of things are yet to get clear.
Okay, madam. Thank you very much.
Okay, so looks like we are done with the Q&A session. So on behalf of all the participants, I sincerely thank Dr. Shilpa ma'am for her enlightening session on decoding the future, the role of explainable adaptive AI in next generation healthcare. Your clear explanations and deep insights into AI applications in healthcare were both inspiring and highly informative. We truly appreciate your expertise and the practical perspectives you shared, which have broadened our understanding and motivated us to explore new avenues in AI research. Thank you for engaging with us, ma'am, so thoughtfully and sharing your invaluable knowledge. Thank you, ma'am.
Thank you so much. Thank you. So I will be sharing my PPTs with you, okay?
Yes, ma'am. Yes.
Okay. Thank you all. Sure. Okay, bye. Take care. I'm taking leave now.
Okay, thank you, ma'am. Yes.
Thank you.
All the participants are requested to be online. We'll start our next session in a while. Hiren sir, are you audible? Hiren sir?
Yes, audible.
Okay, Jiten sir, start the session. Jiten sir. Okay, sir. Okay, sir. Welcome everyone to our second session of the day. It is my pleasure to introduce our distinguished speaker for today, Dr. Hiren Mewada, Assistant Research Professor at Prince Mohammed bin Fahd University, Al Khobar, Kingdom of Saudi Arabia. Dr. Mewada brings over 18 years of academic and research experience, having previously served as an associate professor in electronics engineering department at Charutar University of Science and Technology, Gujarat, India. He completed his PhD and MTech in electronics engineering from SVNIT Surat, and his research spans signal and image processing, ranging from software simulations to hardware implementations on FPGA and ARM processors. Dr. Mewada has focused on signal processing and image segmentation algorithms, as well as video analysis and summarization applications. He has authored of over 100 peer-reviewed publications, one book and four book chapters, and has supervised 6 PhD students, more than 33 postgraduate students, and 50 undergraduate students. His work has been recognized internationally, and he has contributed to several cutting-edge research projects funded by organizations such as BRNS, Guj Coast, and international collaborations. Today, Dr. Mewada will be delivering a session on advancements in advancements in cancer diagnosis, the influence of AI in pathological image classification, highlighting how artificial intelligence is transforming the analysis of medical images and improving the accuracy and efficiency of cancer diagnostics. It is my honor to invite Dr. Hiren Mewada to take over the session and share his invaluable insights with us. Yes, sir, over to you.
Yeah, thank you. Thank you, Dr. Jiten Kumar, for giving my nice introductions. So let me allow to share my PowerPoint first, and then I will begin my talk. Yeah. Yes, am I audible to all of you?
Yes, sir.
Hello.
Yes, sir.
Yes, sir.
Audible, sir.
Okay, yeah. Okay, I hope that my screen is visible now to all.
No, sir.
Yes, is it visible now?
No, sir.
Still not visible?
No, sir. Screen is set, but PPT is not visible.
Just a minute.
Now
It's
it's visible. Yes,
Okay.
now screen is visible, PPT is also visible.
Okay. And I hope that it is changing also, right?
No, sir, still, yes, now changing, sir, okay.
Okay. Okay, fine. So let me begin. So very good evening to all. Hope you are still awake with multiple talks. So I'm Dr. Hiren. Today I'm going to talk about the healthcare applications. And my today's talk is concentrating on the cancer diagnosis, and specifically I'm focusing on the pathological image classifications. So as a part of today's talk, I'm going to talk about I'm giving the some glimpse, introducing the health industry revolutions. Then I will very quickly go what is the AI and the machine learning in diagnosis, focusing on the healthcare applications. And then I jump to the what are the different cancer types are there, how the pathological images will be captured using the staging and the examination scheme. And lastly, what the data sets are available online through which we can do the certain experiments and the simulation works. And then I will focus on the few specific deep learning algorithm based on my research works. And then I will end this talk with various challenges, and then I will list out the various references. So before I begin my talk on the pathological image classifications. Let me talk about what is the healthcare. As the name suggests, healthcare 5.0 that embeds the deep collaborations between the human and the machine, where the skilled professional work alongside the AI, IoT, robotics, and other smart systems, which ultimately helps to improve the medical care. And by harnessing the technologies such as the AI, predictive analytics, and the digital twin and the augmented reality, Healthcare 5 is set to revolutionize the way the care is delivered now. So the figure which outlines, it shows that the various evolution of the healthcare, which is identified from healthcare 1.0, and it goes up to the healthcare 5.0 now. Each phase that focus on the specific aspect of the healthcare and highlight the various strategic differentiators that define the stage. So let me break down these key components in terms of focus and what are the strategic differentiators are there for each 5 phases. So let me begin with the first focus, that initially the focus was the evidence-based treatment model, which is the very foundation for the effective healthcare delivery. And then the new healthcare phase 2.0 is jump that initialize the industrializations by integrating the various components of the healthcare chain. And the goal is to provide the comprehensive service coverage from prevention to the treatment, ensuring the seamless patient experience. Then we have the healthcare 3.0, where the automation plays very significant role, and the focus moves or the shifts to the optimizing the operation to enhance the efficiency and the reduce cost associated with the serving patients. And this information is driven by the technology and the process improvement. Then we have the healthcare 4.0, which focus on the digitizations, and where the digital technology come to the forefront and allowing for the customization of the healthcare services to meet individual patient need. Like we are wearing the smartwatch, which is one of the example of the digital technologies that emphasize is on creating the business model that leveraging the data and the technology for the personalized care. And now we are in the phase 5, that is focus on the personalizations, where healthcare is tailored to the individual unique preference and the need. The strategic differentiator here is the enhancement of the patient's overall quality of the life, moving beyond the just treating the illness to the promoting the well-being. So these are the few different 5 phases these are focusing on. And in the healthcare phase 5, the AI and the IoTs are playing the major role. If I talk about the AI and the machine learning, which are gradually strengthening their impact on the everyday life. and we are believed to have the dominant influence in the digital healthcare for the disease diagnosis and the treatment in the near futures. So let me quickly introduce what is the AI, machine learning, and the deep learning, and how they are used in the various diagnosis process. If you look at the diagram, there are different phases of the diagnosis are stated here, starting from the precision oncology, drug discovery, then the imaging technologies, then the sequencing generations, and finally we have the patient data management. And in all these 5 phases, the role of AI, machine learning, deep learning has been strengthened as of now. And we know that the machine learning is a subset of the AI, where the neural network-based algorithms are developed to allow the machine to learn and to resolve the problem like human brain. In turn, if you go one more step below, that is the deep learning. So deep learning is a subset of the machine learning that mimics the human brain ability. It processes the data to identify the images, objects, the languages, and it can improve the drug discovery, it can upgrade the precision medicines, and it can improve the diagnosis and assist the humans in making the decision. So this is how these 3 parts, and as of now, the deep learning is more powerful compared to the machine learning within the AI for the healthcare diagnosis. So if I want to differentiate that what are the differences are there in the AI and the machine learning. So here in the diagram B, it will evaluate what is the difference between the machine learning and the deep learning. So if you look in terms of data dependency, then the machine learning is very excellent in the performance for the small and the medium sized data set. But when it comes to the large data sets, then it has a certain weakness or the certain limitations are there. And at that time, the deep learning will be the tools which can excel the performance on the big data set as compared to the machine learning. So, in other words, we can say that the machine learning is the subset of the AI which focus on the developing the algorithm which are capable learning from the data and the refining the performance over the time. However, the deep learning employs the neural network based model to imitate the human's brain activity by to analyze the huge amount of the complicated data in the area such as language processing, drug discovery, and the image recognitions. So, and figure C and the D, which mimics that what is the difference in the process within the machine learning and the deep learning, where we can see that in the diagram C, that the image we need to pre-process, the feature has to be extracted manually. We have to minimize the feature based on the certain feature selection approach, and then it can go to the classification approach to classify the type of disease. Whereas in the deep learning algorithms, the pre-processing, feature extractions, and the feature selections all are integrated within the various number of convolutional layers. As you can see that convolutional layers and the subsampling layers are attached, which mitigate all the performance of pre-processing, feature extractions, and the feature selection process. And it delivers the finally decision on the label classifications. So this is how the main difference are there between the AI, deep learning, and the machine learning. Now let me illustrate what are the potential areas are there where AI can be integrated in the diagnostic workflow for the patient with the breast cancers. This is my main focus of this talk, that is the pathological images, or I'll tell as the histopathological images. So basically, in the cancer diagnosis, screening plays the important role, and the screening is used for the early diagnosis purpose, where the mammography is the most common screening test. However, the standard screening using the two-dimensional mammography is not without the caveat, and there is an inherent difficulty in detecting the cancer using the two-dimensional mammography because of the overlapping structure in the pathological digits. So the overlapping structure in the pathological images make challenges during the screening process. If you go with the second stage, that is the diagnosis, as you can see in the figure. And in the diagnosis process, the high density, or you can say that the high proportion of glandular and the fibrous tissues can mask the potential tumor, and it make them appear similar to the normal tissues in the mammogram. So during the screening process, they looks like a normal, and therefore there must be attention, or the attention is required, which directed toward the development and the evolution of alternative techniques for this type of cases. A confirmatory diagnosis can only be established through the histopathological examinations of the tissues, and this is the commonly obtained via the needle biopsies. If I go to the third stage, that is known as a staging. The staging is to confirm the result of the diagnosis, and the last two stages, treatment and responses, are from the patients. If the cancer is at the initial stage, the surgery is carried out and later systematic therapy is used as a post-treatment. So we can see that in the responses, the various radiology or the pathology will play the important role in understanding the informations or the languages from the patients. And again, they have to redefine the treatment for the better cure. So if I look at the diagnosis market, then we can see that the AI in the cancer diagnosis market is growing very rapidly, and it is expected to reach that around 1,943 million US dollar by the 2023 year, and it is increasing from up to the US dollar of 175.3 million. This represents that the compound annual growth rate, the CAGR, is about 27.2% from last 2024 year to the next coming 2033 years. And the market segment based on the component include the software solutions, the hardware solutions, and the various management services. In 2023, the software solution segments led the market by the 46.5%. And in the lower right diagram, we can see that the segmentations or the growth of the market among the three services, software, hardware, and the management service, is listed out over the year. And it is also projected that the growth will be the fastest during the forecast period with notable CAGR. Among the cancer types, the other cancer segment generated the most revenues. Again, we can divide the various cancer segmentations. And if I look here, the various cancer segmentations are there, starting from the lung cancer, breast cancer, prostate cancers, brain tumor cancers, and the colorectal cancers. So among the other cancer segments have been like most revenue. And if I go back here, I'm sorry, I'm going reverse on the forward back, but the hospital remain the primary end user for the AI for the cancer diagnosis, and they have secured the market share of the 61%. If you look at the region wise, the North America maintained the strong hold on the market, and they have contributed around 100 US dollar a year in the revenue point of view. And this segment is prominent due to the increasing introductions of the software solutions established by the market leaders and the emerging startups. And definitely this trend reflects the growing demand for the advanced digital solutions in the healthcare sector. So I believe that this shows that how the healthcare is growing with AI and the new technologies. Further, as I mentioned, that overall the segmentation of the various cancer types encompasses the various cancer types. And the AI tool which predict the cancer likelihood with 86 to 94% accuracy in the laboratory point of view. From the simulation point of view, from the software point of view, it can go up to the 99%. AI-driven diagnostic solution will play the crucial role in early detections, treatment planning, and the patient management in various clinical settings. And the primary restraining hindering AI in the cancer diagnosis market encompasses the data quality, interoperability, and the regulatory compliance challenges. One of the challenges that is the limited access to the high quality annotated data set, which poses the significant barrier to the development and the validation of the robust AI algorithm for the cancer detection and the classifications. So here the few are the challenges which are listed out, which are globally, or you can say the general challenges are there. So let me start very quickly about how the histopathological images are captured. I will go very quickly because this is about the laboratory part, and being an engineer, we are more interested in the processing the images rather than how the images have been captured. So let me start with quick overview of the non-pathological forms and the word pathologies that will help us to who are the newcomers in this area, that will they can have the just idea of how the imaging technology will be used in the healthcare or the diagnosis of the cancers. So apart from the things like genomic testing and the others, the mainstay of the pathology is the attendee stay in the tissue images. The tissues are taken out from the organ. It is put on the glass slides and the stain with a certain contrasting agent to give the contrast in the way that we can see that structure, morphology, and the other things. If you see in the leftmost diagram, one image is shown after the staining process, which is pinkish in the color, and we can see some texture informations, and that is because of the staining process we are getting it. The pathologists normally look at this color stain slides under the microscope. Sometimes they also do the other type of staining. If I give one example, that is known as the IH system, which highlight the different features of the nuclei and the diagnosis it based on what they see under the microscope. So the second part will come to microscope. Nowadays, the microscope comes with the mounted camera, and later we can see in the slide. When I move to the next slide, we can see that. But the things are get revolutionized with availability of the whole slide images. An example of the breast H&E stain whole slide images from the 3 different styles. You can see here. That is the one whole slide image from the BCRA dataset has been shown here, where in the diagram A illustrated the 3 types of the images with the 3 different magnification level, like 10 times zoomings, 40 times zoomings, and the 20 times zoomings. The second diagram B, this indicates the whole slide image multi-resolution pyramid with highest resolution of the level 0, and later on level 1 and the level 2 has the lower resolutions. So these microscopes can scan the entire slug and give us the digital tissue images, which we can share to the computer network and view the over digital monitor to the diagnosis. Many times, instead of zooming over the microscope, we can use the digital zoom on the computer to tweak the tissue structures and to do the tensor grading and the other stuff. Now, the problem with this image is that they are very, very large in the size. If I talk about the one whole slide images, the size of the image in terms of gigapixel, and in terms of rectangle point of view, it is around 100,000 by 100,000 pixels. So the standard techniques that has the scaling problem, and when we are applying these algorithms, in addition, there is a lot of variation within the tissues are there due to the specific type of the cancer. So definitely the development of algorithm is required, which consider the fluidity problem while developing the such computational algorithms. Normally, we reduce the image size to say that up to the 4,000 out of the 100,000 pixels for the each patient, and then we apply the algorithm so that we can minimize the computational complexity as well. We have the other type of imaging that are also available, which increase the throughput. Let's say that we have the 100 patients, and the scanning the tissue image for the each patient will take a time. So what we do that we can take the some spores representing the cancer for the each patient. We mount all the slides on the single slides, all the tissue slides, all biopsy slides on the some single slides, and then we can scan the several patient slides at the same time. So that will help us to reduce the time, and it will increase the throughput rate. So let me give the quick example of the 2 staining process. The one is known as the left-hand side, that is known as the H and E stain image. The full form of H and E is the hematoxylin and eosin staining. And the second staining process is known as the ISC staining image, that is known as a immunohistochemistry staining. If you look at the structure, we can see that in the HFT stage, the image look like pinkish, and that is, and whatever the pinkish color you can see, that is the nuclei and the cytoplasms which are look purple color and the pinkish color, and this happens due to the hematoxylin and the eosin stain. In the normal tissues, the architecture is well maintained and the nucleus are well organized. So what the pathology looks for the how the diagnosis. So normally they look at the texture patterns of the images. It is a normal tissue, then the architecture is well maintained and all the nucleus are well organized. When the region or the organ or the tissues are suffered with the damage through the injury, through the disease. Like if I take the one example, like suppose some wounding are there, some ulcers are there, some tumors are there, then this normal structure will get changed. And based on this change in the structure, they will be classify the image in the two types. One is known as the in situ classifications or invasive classifications. So let me jump to the now. There are two types: in situ carcinoma image, and second is known as an invasive carcinoma image. As I mentioned, in the normal tissues, the architecture is well maintained. So let's say suppose it is an abnormal image is there. Then what are the changes in the structure take place? So here two images are highlighted here. One is the normal image, the first one, and along with the normal, another two type of classifications are there. That is the in situ carcinoma and the invasive carcinoma. In the second image of in situ carcinoma, the cells are restrained inside the ductal lobular systems. If you see here, they are inside the structures. The tissues, if I go about the third part, where the tissues with invasive carcinoma, this shows the distortions of the architecture because the tissues are going out of the circular part as compared to the normal images. So that is the not normal distributions. And secondly, the high nuclear density and the variability we can see. And all the cells will be spread beyond the structures. So this is how the pathology or the pathologists will look at the structure and they try to classify that what type of cancer it is. It is whether it is a in situ carcinoma type or invasive carcinoma type by looking to the structure. However, all the performance will depend on the ability of the data quality or the image quality. If you have the high quality training and the validation data, then algorithm will be suffice to predict automatically as an equivalent to the pathologist. However, like other medical data, for the histopathology images are protected by the ethical and the legal regulations, which is related to the privacy, security, and the consent. And therefore, it creates the major challenge when we are going for the data publications. To share the medical data, the data owner should adhere to the relevant regulatory requirement. If I give the one example, one of the committee that is known as the General Data Protection Regulations, GDPR, that is belongs to the European Union, and the second one is the Health Insurance Portability and the Accountability Act, HIPAA, that is belongs to the United States. So after the GDPR revised in the new regulations by the May 2018, the medical data sharing has become the more challenging due to the concern over the maintaining and the confidentiality about the patient health information, especially in the light of high profile data breaches and the incident of the data misuse. I hope that I am audible and my screens are visible to all of you, right? Hello.
Yes, sir.
Okay. Then I continue. Yeah.
Okay,
So-
you can continue, sir.
Okay. Now, in addition to the privacy and the security concerns, intellectual property and the regulatory issue can pose a significant barrier in the setting the medical data. And resource constraint can also limit the ability of the researcher to sell the medical data. The costs which are associated with the collecting, storing, and curating the medical data also can be substantial, and many researchers may lack of the necessary resources or expertise to manage and share the data effectively. So here the objective is to provide the what are the large data set publicly available through which we can develop the algorithms. So here I have listed out the very large data sets among the different types. So starting from the Acrobat, and it goes to the last BRACS. Each column has the 4 parameters, like what is the size of the images are available into the data set, what the task they are focusing on during the capturing the data set, whether the data set captures the whole slide images or the few patches in the small size images, and what magnification factors they applied on the slide during the digitization of these images, and in which year they have been published. That is listed out here. So it shows that there are different tasks has been shown here, like starting from the registrations, classifications, and the segmentations. So these are the various tasks which have been targeted during the data collections. Most of the images has been collected either the whole slide image or the patches. And each patches have the different size varying from 1K to the 15,000K. Most of the data set covers the 40,000 images, 40 times zooming magnification factors. Very few data set has the different type of magnifications are available. Like if you look at the reference file, that is ANHIR, NP data set, that is used for the registration purpose. And they have the 3 different zoomings or the magnifications are available, starting from the 10, 20, and the 40 times zoomings. If you look further, another data sets, it starts from the Brexis data sets, which go to the GTX portal data sets. Among the all, if you look at the 10th number of the reference, that is the Brexis data set, which contains the both many and the malignant, and again the multi-classification data set is available for classifying the malignant images as well. And this data set is specifically organized for the classification task. And they are available in terms of patch, and this is the only data set which covers the 4 times of zooming or the magnification, starting from the 40, 100, 200, and the 400 magnification levels. So let me go quickly that analysis of these data sets and how this data set has been utilized among the various literatures. So I have prepared the one chart which shows that how this public data set of is actively used for the different algorithm for the development purpose, including the segmentation task, classification task, prognostic predictions, and the color normalization of the histological images. So in the leftmost diagram A, we can see that in the x-axis, the various databases are listed. In the y-axis, which are actively used. Among them, the few are the review papers. So review papers are listed out by the light blue color. And in the right side, the bar chart is shown here that what percentage will be utilized among this data set for the different type of applications. So we can see that the frequency of active use of the whole slide image data sets, and almost half of the studies, like 52% have used the TCGA or the BRCA data sets actively, which highlights the significance of this data set in the computational pathology and it value over the resources for the future study. For multi-class classifications, as I mentioned, only one data set, that is the Brexis data set, is available largely. And it is the only single data set which provides the 4 magnification levels for the image patches. So this is how the various data set has been utilized among the different algorithms. Now, what are the challenges are available while utilizing these data sets? So definitely there are inconsistencies in the data format and the structure. which are found across the available data set, and that will limit the interoperability of the data sets. Let me give one example of the various artifacts and the quality issues in these whole slide images. Let me begin with the diagram or the image A, where you can see that the whole slide image from the BRCA dataset with inconsistent staining is there, and because of the inconsistent staining, the outcome of the algorithm could not be correct. If I go very quickly to the diagram B, that is the folding issues in the whole slide images. In the diagram C, the pathologist markers side on the whole slide image is not correct. Similarly, in the diagram D, a slide from the BRCA which shows the predominantly vacant areas, it is not labeled correctly. In the diagram ED, there is a blurring of the region will be take place because of the marker size on the private data sets. Similarly, in the diagram F, there is a presence of the bubble in the whole slide images, and that bubble will lead to the focal image descriptions. Similarly, in the diagram G, there is a marker size, there is a presence of the marker size, air bubble, and the inconsistent color in the some regions. And in the lastly, we have the whole slide images from the Warwick data set, which shows that the marker signs on the slide. And because of that, the classification may be go wrong. So we observe that among the 149 non-review papers, normally when we do the literature reviews, so we will find the review papers and the research paper. So among the 149 research papers, only 41 research papers have incorporated the multiple data sets. And the 21 papers have integrated the private data sets alongside the public one for the model development and the validations. Notably, only the 21 studies use the external validations of the test data set, which implies that performance of the other developed model could be subjected to the overestimation. So the idea is, what I want to convey is that when we develop the algorithm, it is necessary that the algorithm has to be tested among the multiple data sets. And while testing the data sets, we have to be careful by utilizing these various issues or the inconsistencies available within the data sets. So now let me jump to the what are the essential components are there for the AI-based analysis for these histopathological image classifications. So normally when the data set is available, we start with the pre-processing. So the first step is the image acquisitions, which capture the data from the slides. And then we begin with the pre-processing steps. Then we start with the segmentation step, which is the optional, because if you go for the classification, the segmentation is not necessary. However, it depends on the what type of applications or what is the focus of the application is there. The idea, if the aim is to classify, then we can avoid these steps. Then the next step is the feature extractions. In this step, if you are using the machine learning algorithm, then definitely we need these steps, and we have to extract the feature manually. Manually means some using these another algorithms. And then we have to integrate these features with the machine learning model for the classifications. And if you are using the deep learning algorithms, then the deep learning model can extract the features automatically, and then it can go for the classification stage. In the final classifications, we have the two type of modes are there. Either we can go for the binary classification, that means normal tissues and the malignant tissues. That is one classifications, and the other is known as the multi-class classifications. In the multi-class classifications, we can divide the images again further in the number of different categories of the cancers. So that we are going to see when it comes to the malignant classifications. So let me begin with the data pre-processing. The pre-processing phase converts the original data to the sensors in the structured way such that the most significant features can be identified and analyzed easily. Here I have listed out the various methods which is commonly used into the various research papers, starting from the color normalizations, filtering, denoising, and the enhancement. And In addition to that, there are different quality of the images will be also make a challenges in the classifications or the segmentation, the feature abstractions. So we need to choose the appropriate pre-processing techniques among the listed out from the color normations to the enhancement technique. Apart from that, we can use the morphological operations also, which smoothen the low intensity foreground and the high intensity background, and it can maintain the structure information as well. In addition to that, various different techniques are used to increase the images. If I have the limited size, limited number of images are available in the data set, and we know that for when we apply the deep learning algorithm, we require the large data sets. And to apply this to need for the large data sets, we have to do the augmentation process. Augmentation means we have to increase the number of the images within the data sets. And in the right side column, I have listed out what are the augmentation techniques we used, starting from the rotations, grouping, flipping, and the region of interest detections and the Gaussian smoothing. So by employing this image pre-processing and the augmentation technique, we can increase the size of the data sets. After that, we have the pre-process the image. The next step, as I mentioned, it is not necessary for the classification, and that step is known as the segmentations. The segmentations partition the images into the non-overlapping block. It separates the object from the background that are area of the interest using the techniques. And here I listed out the various techniques which is used for the segmentation purpose, like clustering. Then we have the age-based and the region-based segmentations. We have the thresholding approach. The technique of the segmentation is selected subject to the various type of feature to be extracted. So if I take the thresholding method, then definitely thresholding method has the very fewer competitions, and it can provide the good segmentations. But at the same time, the selecting the threshold is the challenge. If you choose the lower threshold value, then the over segmentation will be take place. Similarly, another method is known as the clustering, where we can use the nearest neighbor method or the mean shift method, which requires the less amount of the data for the process, but it can generate the incorrect cluster if very few pixels are present in the DP. The third method is known as the active contour method. It is just like a rubber band, which can fit to the boundary of the region of the objects, and it can resolve the issue of the overlapping and the obstruct boundaries. And active contour can provide there is no loss of the geometrical feature during the segmentations. The third is known as a watershed technique, which has the less competitions. However, it is sensitive to the noise during the operations, and it can perform the over segmentations. And lastly, we have the neural network, that is the fully automated approach, but it is a computational intensity. The next stage is the feature extractions. As I mentioned, this is the separate stage for the machine learning, and maybe we can remove during the deep learning process. So feature extraction is the required for the classifications, and extraction of the feature is done either at the tissue level or at the cellular level to measure the changes. The objective of the feature extraction is to find the features which can distinguish the benign and the malignant type of the cells. And the most common features used are the intensity, factor, texture, and the morphological features. Nowadays, the texture features have been used mostly because of the pathological image formations, because of the staining process, and they are widely used. Texture features are based on the Gabor filter, CLA transform, local binary pattern, GLCM, gray level co-occurrence matrix, and or we can integrate these features also. And lastly, we have the final stage, that is the classifications. The classifications can be either binary or the multi-class. Binary means, as I told, it is either could be benign type, normal, or the malignant type. In the multi-class classifications can be further classified into the subclasses as it is listed out on the right hand side lower table. So it could be classified in the 4 further categories: ductal carcinoma, lobular carcinoma, mucinous carcinoma, and the papillary carcinoma. So these are the overall, we can classify either into the 5 or the 8 categories in the multi-class classifications. Okay, so now let me concentrate on the ENN model or the deep learning model, which are largely utilized for the histopathological images. If we categorize the deep learning model, then I can categorize into the three classes. The first one is known as a GAN. GAN means generative adversarial network. Then we have the CNN, convolutional neural network, and then we have the large language model, LLM. The CNN model is widely used for the classifications and the segmentations for the object detections. So let me go very quickly about the all three models, and then I will concentrate on the CNN model for my research work. So generative adversarial network are the class of the machine learning framework which is designed for unsupervised learning. It is primarily used for the generating the new data samples that resembles the given training data sets. So the idea is to develop the new data sets from the training activity. And it is consist of the two block or the two component. The first block is known as a generator component, and the second block is known as a discriminator component. In the lower block diagram to the left hand side, I have shown the block diagram of the GAN, where the random noise will be added and then it will pass to the generator block. Generator is represented by the G block. The generator role is to create the new data sample, or you can say that it generates the fake images using the random noise. Normally the random noise is created by the Gaussian distributions, and it produces the data that is indistinguishable from the real data in the training sets. Now, to see the effectiveness of the generator, what we require to compare the fake images with the real sample images. And now further we need to classify whether the image is real or the fake. And to perform that task, the discriminator is used. The discriminator acts as a classifier, and it distinguishes between the real data or the real training set and the fake data which is produced by the generator. If the output of the discriminator, which gives in terms of probability score, and if the probability score indicates whether the given input is real or the fake, and thus discriminator feedback will help the generator to refine it. So if you look at the diagram, the generator will define the probability that how it would be able to classify the fake images from the real images. If it is able to discriminate well, then again we have to refine the generator block well such that more fake images which resembles the real images can be generated back. So this is the iterative algorithm which works on the feedback from the discriminator, and then it can be applied. Now, what are the challenges where we can work? What are the research as of now is going on? One of the main issue that this GAN faces is the limited size of the data set. Obtaining and annotating the histopathological sample is both time consuming and a labor intensive task. Here, GAN shines by generating the synthetic images that closely resemble the real samples, and definitely the augmentation can increase the diversity of the training data. And this way, it allows the classification algorithm to learn from the broader range of the examples. Additionally, we often encounter the class imbalances. Class imbalances means we have the large number of the normal tissues and very few sample images of the malignant are available. And that is known as a class imbalance problem. And for the few cancer types, they are underrepresented, and that can lead to the biased model performance. So by generating the synthetic sample of these real rare care classes, definitely GAN can help us to get the diverse data set or the balanced data set, and then we can create the classification model in better robust classification model we can develop. Now the challenges are that most of the images may suffer from the noise and the various artifacts, and that can obscure the important detail, and the GAN can enhance the image quality by converting the low quality images into the high resolution images. And this improvement in the image clarity lead to the better feature extractions as compared to the normal regular dataset utilizations. Next, we are going for the second classification, that is known as a large language model. The LLM can see the images and have the language to describe the content of the images. So it can see and it can describe the image. So given that LLM are adept at handling the variety of the general purpose natural language processing tasks like sentiment analysis, entity recognitions, text classifications, it is also interesting to consider whether this vision-enabled element would supplement the traditional image classification method in general purpose way. So the idea is that mostly the LLM are used for the text classifications only, but now we are changing the role of LLM for the classifications point of view. And one of the key advantage of the LLM is lies in their ability to contextualize the image with corresponding natural language description and the use of the transfer learning. This approach is more advanced than the traditional image classification method, which primarily rely on the analyzing the visual features. Overall approach has the 4 stages, as you can see in the lower diagram, from stage 1 to stage 4. The stage 1, that is, we need to integrate the NLP and the GNN, and we can propose the novel approach for comprehensive analyzing of the histopathological reports, because the report is the descriptive in the nature, they are not the images. So studying the report automatically using the NLP can make the model more robust, and they can understand the pathological language formations. Secondly, we can use the attention score of the LLM, that is the second stage, attention score, that can construct the interpretable and the context-aware graph representations. Then in the third stage, we can incorporate the feature extraction stage that identify the critical variables for predicting the cancer metastasis, and that enhance the model's predictive accuracy and the interoperability. And the last stage is providing the clinicians with robust approach that can provide valuable insight into the underlying data and facilitating the more informed decision making and the improving patient outcomes. So now let me focus on some advancement, particularly focusing on the hybrid network and the modified CNN architectures which are developed recently. When I say the hybrid networks combine the traditional CNN with other machine learning networks, and this way we can boost the performance of the classifications. So now the CNN could be further classified into the 4 categories. As you can see, the hybrid network, modified networks. Then we have the deep learning with future fusion model, and we have the explainable AI for the classifications. When I talk about the future fusion techniques, when I am talking about the modified CNN networks, it means that the researcher will tailor the models. We are modifying the algorithm of the CNN layers specifically for the complexity of the histopathological images. If I look at the third classification, that is the future fusion model, which has gained the large popularities nowadays. So what we can do, that the one model extract the feature using the multiple pre-trained networks, and before combining them for the classifications, so the various features from the different algorithms are concatenated together before the classifications. And this approach can maximize the strength of the different architecture, and that can help us to enhance the overall performance classification rate. And lastly, we have the 4th category, that is known as an explainable AI, because normally when we talk about the deep learning or the CNN network, they are considered as a black box. Black box means we don't know how inside the algorithm works, and still we are able to get the accurate results. So the idea is that in the explainable AI, the modified CNNs are being developed not just to classify, but also to provide a visual explanation that why the model has taken this decision. And to provide this visual explanation, the heat maps are utilized, which indicates that which area of the image contributed most in the decision process. So among these 4 types, there are different models are there. So now I'm going to concentrate on my research works. So traditional CNN architectures, as we mentioned, are the predefined CNN networks which extract the spatial features only because they are utilizing convolution of operations. And in the convolution, spatial features are extracted only. And histopathological images depends on the structure or the texture patterns, or we can say that they are known as the spatial temporal features also. And one of the approach to extract the texture pattern or the structure or the pattern of the tissue images is based on the wavelet. The wavelet transform can discriminate the structure well using the local features in the spatial domain as well as in the frequency domain. So wavelet, let me just give you the brief idea. What is the wavelet? Wavelet is the one oscillating function that is used to present the data both at the scale and the positions in comparison to the Fourier transform. And therefore, wavelet is able to capture the both frequency and the location of the information from the images. So wavelet can capture the texture features at the different scales and the orientations. And to explore this texture information from the histopathological images, a variety of bases of the mother wavelets can be used. Like we have one of the mother wavelet is the Harvey wavelet, Dobens's wavelet, singlet wavelet, Coiflet wavelet, and the bi-orthogonal wavelet. As the indicative illustrations of this wavelet transform, which is applied to these various styles of the images, which is shown into this diagram or the image to the right hand side, where you can see that the original image can be divided into the number of the 4 scale using the different mother wavelet. Like first one is the bi-orthogonal in the lowest left side. Then we have the Coiflet, Dobens's, R, and the so on. So our idea is that we want to fuse the features which are obtained from the all resolutions into the deep CNN network. And the intuitive diagram for the proposed model is shown into the diagram, shown in this slide here. There you can see that the wavelet transform is applied to the original image in the left hand side lower image, and we obtain the 4 decomposition level. When I say the 4 decomposition level means 4 different resolution levels have been obtained for the historical images, ranging from 512, then the original, let's say that original image size is the 512, then it will be goes to the 256, then 128, 64, and so on. So different levels are there. Then various number of filters with a different size are used in each convolutional layer. If you look in the diagram, the image goes to the wavelet transform, and from the wavelet transform, it goes to the deep learning layer, that is the convolutional layer, which has the different size of the filter, starting from the 512, 128, 64, goes by level layer 1, layer 2, and layer 3, and so on. Later on, the best normalizations are used after each layer in the CNN layer to improve the poor convergence problem. Additionally, to increase the speed of the training process, a ReLU activation function is also used as an internal layer after the normalizations. And lastly, the max pooling operation is used to reduce the feature vector size from the output of the activation functions in the CNN layer. And the performance is carried out on the 2 public data sets. The first data set is the Breakfast data set, and the second data set is the IEC data set from the breast cancer classification challenge. And the table shows the analysis of the model. So as compared to the regular CNN network, which has the very limited accuracy of 77%, If we combine the CNN with the machine learning SVM model, it reached the 83% accuracies. And other augmentation technique with CNN model can reach to the maximum accuracy of 90 and 86%. As compared to that, if we extract the evaluated feature and we integrate the feature internally to the CNN layer, then we can get the classification rate for the multi-class classification will be greater than the 97% for the all the tuning factors starting from the 20, 40, 100 and the 400 magnification levels. So this is first we initiated the work by integrating the texture features in the CNN layer. Then we move to the another texture features that is known as the local binary pattern, which is the powerful and efficient descriptor mostly used in the image processing and the computer vision applications. It will label the pixel in the image by the threshold being the neighborhood of each pixel, and then it converts the result into the binary number. To explain the idea of the local binary pattern, here the image is shown here. Let's say that this is my original image and I am capturing the 3 by 3 region out of the image. So total 8 pixels are there with a radius of the 1. The neighboring pixels are compared with the center pixels. If you look at the diagram, the black mask center pixel is shown into the third box, that is known as a binary pattern extractor. So neighboring pixel is compared with the center pixels, and the pixel value which are bigger to the 0, and then we assign, after the comparisons, we assign the binary logic 1 or 0. If the pixel values is smaller than the center pixel values will be assigned to the 1, and the pixel values which are bigger than the center pixel will be assigned the binary logic 0. By assigning the binary values, then we can have this, we apply the calculation of decimal values based on this binary number. So if we look at the suppose clockwise directions, if you see the decimal value that is created in the image, that is 0, 0, 0, 1, 0 and the 111, and that will give us the one decimal number. Suppose this is the 23. So this way we can create the local binary feature. A local binary pattern will be extracted by moving the slides for the 3 by 3 this grid over the image, and we can create the histogram of the image, and that is known as a local binary pixel based histogram. And that histogram is treated as a feature vector for the original image. Now, what is our contribution is that we reformulated the LBP. We reformulated the LBP as a one type of convolutional operations. Let me redefine that how we reformulated it. You can see in the diagram there are 8 matrix are shown here, or the 8 3 by 3 matrix are shown here. Where each matrix of 3 by 3 will represent the one windows that will scan through the entire image of the overlapping faces. Now, in the each 3 by 3 patch, we have the different encodings are involved. Different encoding values are involved. Let me start with computing the difference between the pivot, that is the neighbor, center, and the neighboring pixel. So if you look in the leftmost diagram, if you look at the first row of the matrix, the first only one pixel has the value 1, and the center pixel is -1. So as I mentioned, in the LBP, we need to compare the values. So we multiply this mask for the filter to the image, patch, and then we compare the results, and we can get the local binary pattern values. And by using this 8 different masks or the 8 different filters, we can perform the entire LBP calculations. And the advantage of this method is that we can perform these operations parallelly, simultaneously over the image. So the idea is that instead of applying this, we can use this mask as a simple convolutional operation over the 3 by 3 filters, and we can achieve the local binary pattern way. And later on, we can apply the Heaviside functions because we have to take the threshold to determine whether the center pixel is larger than the neighbor pixel or not. So here you can see in the equation, Vi is my threshold for the Heaviside functions, which will help us to get the decide whether the center pixel is larger than the neighbor pixel or not, and then we can create the binary labeling of the each pixels. And then we can create, by summing of all the binary labels, we can create a histogram. So that what is the advantage here is that the number of learnable parameter in this LBC layer, so we define as a local binary pattern convolutional layer now with 1x1 convolution, and the number of learnable parameter is significantly less than the which we use as a standard convolutional layer for the same size of the CNN kernel compared to the number of input and the output channel. So let me show the calculations now. So here you can see that by integrating these features, how much number of parameters we can reduce. So here you can see that the number of, in the numerator side, we have the number of CNN parameter. In the denominator, we have the CNN network with LBP based convolutional parameter. Let me explain that let L and the K in the equation. The L and K represent the input and the output feature map respectively. And the size of the convolutional filter is defined by the N by M. Suppose if I use the 3 by 3 filter, then this is a N by M, that is 3 by 3. And let's say that the P is the intermediate channel. The ratio of the required parameter from the standard CNN to the LBP formulated, which is expressed by the ratio of these two. And we can see that the number of parameters will be reduced. If we look at this based on these calculations, we can see that the regular CNN architecture requires, with 20 layers, requires approximately 10.52 million learnable parameters. However, the same CNN networks with 20 layers modified with the LBP directed CNN networks require only 1.56 million parameters. So on an average, we are able to reduce the number of the parameter by 6.72 factors. Thus, we can reduce the learnable parameter size in the traditional CNN model by introducing the local binary pattern based convolutional layer, and that will enhance the, and that will maintain the same accuracy level that we can get using the regular CNN network. So now let me provide the outcomes of the model. So here one analysis over the different magnification is shown here. And you can see that the model obtained the average accuracy of 96% on the Breakis dataset, irrespective of the different magnification levels. In addition to that, the classifying accuracy does not provide the complete, and the accuracy is not only the, if you look at the accuracy, it is not the complete information. And therefore, we have to look for the precision and the recall score. And the balance between the precision and recall is given by the F1 score. And if you look at the F1 score, that is also more than the 96%. So that means the model is not biased among the data sets in the classification purpose, which can be validated by using the F1 score. And the overall algorithm or the model structure for the proposed one is shown into in the figure that reads the three color image. Then we apply the LBP filters, then we apply the rectified linear unit, and then we use the regular CNN layers, and that is replicated among up to the 20 layers altogether. And finally, we have the softmax layer for the classifications. And this is how we can obtain the same performance of the CNN networks with reduced parameter by 6.72 times. So this is the advantage we receive using this. Now, in above these two approaches, if I look here, I use the either wavelet feature or the local binary pattern based feature. So we require the manual extraction of the features in addition to the CNN layer. So in comparison to that, so we are moving further ahead and we are moving to the another network that is known as the residual networks. And we are trying to remove these texture features. We are trying to extract the texture features without incorporating the manual feature extraction stage. That means, I want to extract the texture features within the CNN layer, and therefore we propose the new layer that is known as the extended deep learning using the residual features. Now, what is the idea? That the traditional CNN that uses the pre-trained layers and the trainable convolutional layer to extract the spatial features. And these layers provide the global features, ignoring the local features, as I mentioned, factor of the texture patterns. And therefore, we need to extract the texture features within the CNN layer. And we also wanted to maintain the global features because they are very effective in identifying the texture pattern as well. So what we did, we look at the previous architecture at the same time, which are not able to extract the global features. So what we did, a global average pooling, which is used in the CNN, that eliminate the dependency on the spatial locations by averaging all the features, and we can add the robustness to the spatial features obtained from the CNN layer. So that's what we can do. That is the global average pooling we can use for the spatial features. And then we propose an alternative approach that is known as a multi-step model, which employ the global feature extractions, local feature extractions, and then we apply the dimension reduction model simultaneously for the classifications. So let me represent what is the redundant features, how to get these texture features by using the residual features. So here in the diagram, you can see that image is shown here, where let's say that the XL minus 1, that's the feature we obtained from the previous layer of the CNN, which pass to the multiple blocks starting from the weighted layer, activation functions, and the weighted layer. And overall, this weighted layer, the output of this activation function can be expressed as XL, where L is the current layer and the L minus 1 is the previous layer. If I want to express this mathematically, I can say that there is a one skip connection is connected between the previous features and the present features, which are concatenated. So I can say that the overall feature can be expressed as XL minus 1. So previous features are added using this skip connection to the output of the weighted layer, and the weighted layer output is expressed by the R of XL minus 1 comma WL minus 1. So that is the weighted output because of the activation functions on the on the lower line. And if I look at the R will give them a residual features, because what is the R? That is the XL and the XL minus 1, because we are processing the image. So that is known as a residual features. And this residual feature can be obtained by the ResNet network, which is a very popular DIC network, which provides the residual feature. However, the interpretability of this feature is very limited because the skip connection do not interpret the meaningful information. This skip connection do not have any meaningful information. It just pass the feature from previous layer to the present layer. So our primary objective is we want to make it learnable. So what we did, we make the skip connection, we modify the skip connections here. So in our model, what we did that we use the pre-trained DashNet network, DashNet 161 architecture. We modified it by adding the proposed residual network. If you look in the residual network, that the skip connection is changeable. In the skip connections, by adopted with the one kernel of 1x1 convolutional operations with the stride of 1, and then we have the sigmoid functions. I hope that you are able to see the upper row or the upper branch of the image in the residual layer 1 part within the same images. In the lower branch, we have the 3 kernel or the convolutional filters are there, like 64 1x1, 64 3x3, and 1 cross 1 256. Overall, this architecture is part of the residual features which we are extracting, and our modification is on the skip connections. The idea is that the role of the kernel, that 1x1 kernel in the upper branch, is to provide the new learning features from the pre-trained features at each pixel locations in the image, and the size of this outcome of 1 by convolution is similar to the input. It is not changing the size of the feature. And later we applied the sigmoid functions that emphasize the difference between the newly learned features and the pre-trained features. Thus, the kernel in the modified skip connection will give the local features at each pixel, and it can be concatenated with global features which could be obtained from the lower branch. The lower branch which has the three kernel like 64 1 cross 1, then 64 1 cross 1, and the 64 1 cross 1. The lower branch we have the three additional sub branches which provide the global informations. And the upper branch will give the local informations, and by combining the local information with global information, we can improve the performance of the model. And lastly, we utilize the dropout and the batch normalization process, which you can see in the vertical form, ReLU, batch normalization, ReLU, and the global pooling. Then we will solve the problem of overfitting. So to solve the problem of overfitting, the batch normalizations and the dropout is utilized. So if you look at the performance now using this model, so we can see that the average accuracy for all the magnification is large, more than the 97%. For the binary classifications, we obtain the accuracy about 95%. And it is observed that the precision and the FN score for the PC images at 100% is lower than the other classes. So what we did the Albeson study at different magnification levels. And again, within the malignant images, there are four categories are there. That is the MC, LC, DC, and the PC, as we categorized in the very beginning of this discussions. So the four classifications, and when we studied that what accuracy levels are there for the each classification, so we observed that for the PC type malignant images, the accuracy or the precision score is less as compared to the other type. So this is the weakness of the model which we observe for this model. If we compare with other traditional models like DanceNet network, convolutional neural network, VGG network, or the another residual network which is proposed by in another research work, it has been observed that the proposed model has surpassed or give the better performance as compared to the other models. And only the major limitations of this model is that the PC images are not classified as expected, and accuracy is limited to the 82% only. And this these limitations may be because of it relies on the trained feature sets of the pre-trained network. We use the dense network, and this may create the limit or applicability if the previous model is not trained well. So this is the one model which we categorized. Later on, we move to the same skip connections and we try to improve the performance of the model. We again approach the same learnable skip connections, but here again we modified it in the skip connections. As you can see that in the ResNet network, the skip connection is directly connected without any layer. But here in the previous model, if you look here, we use the 1-by-1 convolutional layer in the upper branch. Now instead of the 1-by-1 branch, we use the 2-dimension convolutional operation along with batch normalizations. So our idea is that the major weakness of the previous model is that they require the large number of the layers. They require the large number of the learnable parameters. And secondly, the choosing the hyperparameter is again crucial for adopting this CNN network, because we have not optimized the parameters in the previous model. And because of that, there might be chance that the precision defaults or the balance FN score may be limited, or we cannot improve at further stage. And therefore, we propose the one optimization of the ResNet network, introducing the learnable convolutional skip connections, but again it's not similar to the previous one. And further, we optimize the parameter using the ELO algorithm, and then we try to reduce the number of the parameters. So as I mentioned, the skip connection has been modified as shown in the diagram. and we introduced the 2D convolutional with the best normalizations in the skip connections, and because of that, it allows the gradient to flow more easily throughout the network during the web propagation technique. The overall block diagram of the proposed approach is shown here. Maybe text are not visible clearly, but I will go very quickly that we started with the images, then we apply the pre-processing stage, and then we apply the augmentation of the images. Then we divide the image into the 3 data set, training, test, and the validation data set. And then we apply our adapted residual network with ALO optimizations. ALO means ant lion optimization technique is utilized to tune the hyperparameter. And later on, the optimized network, modified network is utilized to evaluate on the breakage data sets. Initially, during the pre-processing stage, 256 by 256 images are extracted from the whole slide images with a slide of 64. And we ensure that it can focus on the smaller region, but it will not generate the redundant informations, because redundant informations will cause the overfitting of the model during the training stage. And by modifying the structures, resonant network, we observe that we are able to create even efficient network after the optimizations up to the 74 layer. So our model requires the 74 layers with 5.2 million parameters. Now, when we evaluated the model on the 2 different ways, the first is classification for the both binary and the multi-class classification, as well as comparing the model with a different optimization algorithm, as well as traditional model. The first table represents that what the literature has been shown, what the different optimization algorithms are used along with CNN layer. Like in one of the literature, it has been shown that they utilize the FS ResNet. Another author proposed the particle swarm optimizations. Another next author proposed the ALO and the PSO hybrid network, hybrid optimization algorithm with LSTM networks, and so on. And if we compare the algorithm, we observe that our model accuracy is similar to this optimization model. But what the other benefit we achieve is the learnable parameter and the size of the parameter and the training time. The lower table compares the model with what is the number of parameters, what is the training time, and how much accuracy they receive. Like suppose if I compare with the DashNet 121 network, it requires 7.88 million parameters. If you go with the Inception model, this requires 27 million parameters. If I look for the ResNet 50, definitely ResNet 121 and other ResNet network has the very large trainable parameter as compared to the ResNet 50. And the base is the ResNet 50. So we compare with the ResNet 50, which has the learnable parameter of the 25 millions. And if you look at the accuracy levels, we have obtained the either better accuracy or equivalent accuracy of the 95% or the 96% around among the all magnification levels, among the both binary and the multi-class classifications level, with training time of 126 seconds only, and with learnable parameter of 5.2 million. So this shows that how the model is strengthened by reducing the learnable parameter, by reducing the training time, and maintaining the accuracy of the proposed model. So this is what as of now we have contributed. Now I am going for the how to validate the various AI models. We can say that it is according to our observations, the AI is not only to increase the radiologist performance. As I mentioned that at clinical level, the accuracy reached to the 79% without AI, and with AI it is increased up to the 85%. But it also reduced the reading time up to the 50%. Like previously, the reading time was 64 seconds without AI. Now, because of the use of the AI, the time is reduced to the 30%. So The Future AI Guidelines. There is a one website that is known as the Future AI, which provides the 6 essential principles like fairness, universality. You can see in the slide fairness, universality, traceability, usability, robustness, and the explainable ability. So this fairness will increase the clinical trust and the adoption of the AI into the medical imaging. Definitely universality, this principle recommends that the definition and the application of the standard during the AI development and the evolution and the deployment, and it will increase the interoperability and the applicability of the AI among the different clinical centers, because one clinical center, one laboratory uses the different steering process, the another lab uses the different steering process. So maybe the same AI model could not succeed well for the another lab. When we go for the traceability, the AI algorithm should be developed with mechanism for documenting and monitoring the development process, and as well as be paired with the method to continuously and periodically monitor the functionality in the clinical environment. If I give the example, monitoring tools to identify any discrepancy or any drift which is expected from the behavior, either in terms of accuracy and the interactions with end user, and to plan the maintenance interventions with nurturing the AI model. The third is the usability. The tool must be usable, acceptable, and deployable for the real world end user. And that is one of the focus which I talk by reducing the number of learnable parameters and the size of the model so that it could be effective in the real time by reducing the learning time and the classification time. The third is next is the robustness. The performance and the accuracy when it is applied under the highly variable conditions that must be encountered in the real world and outside the control environment of the laboratory where the algorithm is built and initially tested. If I give the example, development of the model should include the multi-center and the multi-vendor datasets, which are the major weakness as of now in our model also. And lastly, we have the explainability, that is the medical AI algorithm should be able to provide the meaningful and the explainable explanations. As I mentioned in the very beginning, the heat map is the one of the way to explain that why this model performs and gives this accuracy level. That is known as the explainability. The other challenges are the standardized protocol lagging, the variation which introduce the bias and the hinder the model generalizability. So we need the further studies to assess the consistency of the AI performance across the different clinical settings and to build the personal training strategy. The another challenge, as I told very in the beginning, the limited availability of the curated data sets. Most of the AI algorithm for the cancer detection described in the literature employ the single model or the single DPT images or even the patches of the images from the single time point of the making predictions. However, in the real clinical scenario, radiologists also consider the other sources of information that are extracted from the prior images, even other data from the patient medical records. So future AI decision-making algorithms should take into account all the relevant multi-source data. That is also the weakness, that we are using the only histopathological images, but we are not using the other clinical informations. And that will enhance the software performance on the same time. Now let me introduce what are the CNN challenges in the recent algorithms. The few recent approaches which are largely published nowadays. And among them, one of these is the Vision Transformer. The next one is the YOLO series model. And the third one is the large language model. The Vision Transformer, which feeds the image as a sequence of non-overlapping patches and feed these patches into the transformer model. And by treating the image as a sequence rather than the grid of pixels, because if you look at the previous model, we are using as a matrix for the grid of the pixels. But in the Vision Transformer, we are considered as a sequence. And based by considering as a form of sequence, the Vision Transformer, VIT, can capture the long range dependency like previous image and what is the present image difference are there. And the global at global level, which and we can use whichever missed from the previous stages. So that is the one of the advantage of the vision transform. However, there are issues are there that it requires a very high computational cost, which could limit their adoption in the resource constraint setting. And furthermore, the vision transformer usually requires very large amount of the labeled data to train effectively, and which is the major challenge because the limited availability of the annotated images in the medical domain. The second series is known as a YOLO, which is the faster and the more efficient than the traditional method, like CNN, in compared to the CNN. It will annotating the bounding box for the training YOLO can be labor intensive because this YOLO network requires the bounding box. And this is major challenging, especially in the complex images with overlapping structure. And many times YOLO struggle with the class imbalance when the certain classes are underrepresented in the training datasets. The third is the LLM model, which are primarily trained on the textual data and may require the extensive fine-tuning to adapt the specific language of the histopathological reports and the descriptions. The effective integration of the textual insight with visual data from the pathology images can be complex and it requires the sophisticated architectures. So the output from the LLM can be difficult to interpret and it may pose the challenges in understanding the diagnostic reasoning. So these are the three recent models where we can work out, and I have listed out the various challenges at the same time. The other challenges with respect to the CNN is based on the autoencoder model, and the attention-based models are there. An autoencoder is a type of CNN network which is used for the unsupervised learning, and primarily it is used for the data compression, feature extractions, and the noise reductions. However, the designing the effective autoencoder for the feature extraction in the high dimensional pathological images can be challenging and it requires the extensive tuning. The further challenge is that autoencoder can easily overfit to the training data, especially if the data set is small or it is not diverse enough. Many times, attention mechanism is placed and it has greater importance on the given part or the parts of the input. So during the attention mechanism, it gives the more weighted to the particular regions. Like the first attention model was used to improve the performance of machine learning translation tasks. Nevertheless, due to the outstanding results achieved in the NLP task, other variant of attention starts being proposed. The convolutional layer used to generate the attention score. You can see in the diagram that the train images are there, the test image data sets are there, then we have the feature abstractions as a second block. Then we use the encoder for the attention module. We generate the attention score like global average pooling, summarizing the feature map to the single values per channel. And then we can apply to the feature map to generate the attention score for the each spatial locations. And later this attention score are normalized using the softmax functions to produce the probability of the distribution over the spatial dimensions. And this results in attention map. However, it increases the training time, it causes the instability of the model, and many times it introduces the biases and the error in the model. There is a limiting the generalization and adapting the model over the multiple processes. These are the challenges. We can use the attention model to do the scaling there, and further we can develop the models. So thank you very much. So we are stopping now. I will be happy to answer any questions. Please. Thank you for your patience and let us be tomorrow. Thank you very much. I hope that I'm at the time. Yes, sir. If the participants have any questions, they may ask me. That question is there.
Hello.
Yes.
So I need to ask you that if I want to use auto encoder with CNN, where I should look? In which level?
Auto encoder is an additional layer, like the CNN layer. After extracting the CNN layer, you can use like two type of attention mechanisms as well. One is called as the spatial attention, like spatial attention, and the temporal attention. There are the two separate layers as well. So after the conversion layer features which you are obtaining, you can introduce the attention layer, and then again you can feed that attention mechanism from the output of the attention layer to the next layer of the CNN layer. That is one of the approach. The second approach is that once you apply the completely CNN layer and whatever the outcome or the features of the CNN have to be obtained, then you can directly pass to the attention layer, and the based on the score of the attention layer, you can classify it.